Welcome back to my channel, and today we will together solve the daily LeetCode problem. And so for our today problem, that is the problem of maximize the minimum power the city. So this one is like the typical problem for the min-max problem. And for this problem, we typically use the binary search. However, like the difficult thing for the binary search is that that is not the thing like how can we implement the binary search, but it is the problem of how can we validate the array. It is valid or not. That is the condition for to choose the range. Yeah, so this is the hard problem, but I don't think that is too difficult because like in terms of the intuitions or like in terms of the logic, it is just because of the things like we combine so many kind of the techniques, so that's why it would be the hard problem. Yeah, so let's demystify the problem together. Yep, so it means that in here we are given an array, and then with this array it denotes for the number of the power stations for each city. So it means that in here like for the index 0, 1, 2, 3, and 4, 5, in here like each index it denotes for one city. And in here the r in here it means that I think that is the radius. For example, like you are given a city, and then like your power station can have can have impact on the neighbor cities. Yeah, so that is the R in here. It will define the range from one city, and then it will have effect to another. And in here like we still have another parameters, which is the K. For the K, it means that like somehow we can build more 23 power stations and to satisfy some kind of the given problem. And then our task is to find the maximum minimum power of the city using the K in here. It means that K is something like we can build, and then like what is the maximize the minimum power of the stations. Yeah, so in here one thing I must notice in here is that like we must use all of the K. Yeah, for example, yeah, so yeah, just firstly we need to get some kind of the intuition. So how can we get that? Okay, firstly we can see that like because that is the range, right? And then we can imagine it is like the sliding window. Let's say that we are in the first index, and then the range, like the radius in here is 2, right? It means that it has an effect to their neighbors, right? Yeah, it has effect on the right and also on the left. And in here like because the r is 2, so it means that it the first one can affect to the second one and the third one. So yes, so it means that like the neighbors also have effect on this one as well. Yeah, so how can we calculate this one? So you just need to imagine that we are using the sliding window, and when we keep moving to the left, and then sorry, on the to the right, and then the sliding window will expand. And also, for example, you go here and then it would be like this for this one, and then when you come here, and then this is the sliding window. You just need to imagine that, and then so for now we will try to calculate to get some kind of the intuitions. Yeah, okay, so for that we can see that like for the first one, for example, we try to calculate the first one. So that would be 13 plus 12 plus 8, and then what is the first element? That is 33, right? And how about for the second one? The things will be moved here, and then we are in here. So we have what? We have the plus 14. So this one would be 47. Okay, so for the next one we will be here, and then the window will expand here, right? Okay, so what will be? It will be we plus 7, and that would be 54, right? And what is the next element? Next element we will be here, and then it means that it will be like this, and then it means that we are here, so we exclude the 13 here, right? Okay, so what is that number? So it means that this one will be minus 13, and then that would be 41. And when we move here and then we exclude the 12, and then it means that this one minus 12, and then that would be 29, right? Okay, so for now, we have the the number of the power stations can serve a city. And let's say that how can we find the things for the min-max problem. So for the min-max problem, and then so yeah, we need to propose something, right? Let's say that in here I propose that the max, that would be the 53. And then the things we need to do here is that like we need to utilize all of the available stations, and then we need to allocate it to somewhere in this array to satisfy the conditions. We need to check that if this max is possible. Okay, okay, so how can we do that? Yeah, so we will look at this. Okay, firstly, let's say that we will iterate through the first element in the array, and then because like the number of the power stations in the first city, it is not enough to satisfy the max of the 53, for example. And then how can we deal with this problem? Okay, so it means that we need to build more power stations, right? Okay, so the question in here is that like where should we put the power station? Should we put it in the index 0? Should we put it in the index 1? Or should we put it in the index 2? Okay, so the answer in here is that like we should put it on the furthest point in the range, because like we are in the first index, right? And the furthest point on the range to the right, that is like the index 2. Okay, so you may ask me why should we do that? Okay, so let's say that like we okay, so let's say that we build all the things on this one, right? On the very first index, I mean like the current index. Okay, so it means that this one, it will beneficial for the next one, for the first one and the second one, and maybe on to all the things on its left. However, because we are iterate from the left to the right, it means that, for example, if you still can reach to this point, it means that all of the point on the left has already satisfied. And then we should build the power station on the furthest point on the right to beneficial for more power, more cities in the on the right, because like this is the future and we don't know, so it means that we try to benefit them as much as possible. Okay, so that is the first thing. So with this logic, and then somehow like we need to, for example, like in here, if we are looking at the first element in the array, and we can see that it is not enough, and then we should seek to the for this element on the right, and then we seek for the city, and then we will build the power station in here. So this one index 0, right? And the radius in here we have, that is the 2. So it means that somehow like we put all of the power station in here, that is the index 2. Okay, so how many power stations we need to build in the second city? Yes, this one should be third, right? With index 2. Okay, so it means that in here we have 23 available power stations. How many power stations we can have here? So that is the 53. We need 53 minus 33, right? That is 20, right? That is 20. That is 20. Okay, so with this 20, we build more 20 here. So it means that okay, so it means that like here we have 33, we have 47, we have 54, we have 41, we have 29, and in here somehow like we have 20, we can build here 20, right? And then it will be this one also plus 20, this one also plus 20, this one also plus 20, and this one also plus 20. Okay, so we can see that like if we just build something here, and then it is not beneficial to its left but also to its right as well. So that is very important, because we are seeking to do something which is beneficial for the future. Okay, yeah, so it means that like in here with building 20 in here, the first element becomes satisfied, right? Because that is 53 already. this one satisfy, and then we check this one. Okay, we move to the right, right? We check this one. Okay, this one satisfy. Okay, we check this one, and it has already plus 20 satisfy. However, like in here, we have 20 plus 29, right? It is not satisfy the conditions. And how many power station left we have? This one is just like yeah, 29. Okay, so how many power station we have left? So that is the 23 minus what? Minus 20. Okay, so how is that? Like it would be 3. We only can build more 3 power stations. And then in here, like we have 49, only 49 in here. However, like in here we have a max of 3, so it means that like in this one we only can build more 3. So in here, that is the 52, that is smaller than the 53. So it means that like with the proposal of the 52, it does not satisfy the condition, right? Okay, so in here, like we can see that in here, that is the way for us to check. But you may ask me that like, okay, so this is very easy problem, because like we can define the things from the very beginning, and there is no update in the middle in the array. Yeah, so I mean that in here, like let's say that we have multiple update in the middle of the array, and then so it means that we need to, let's say that you update the sub array, and then so you move it here, right? And then you need to update multiple sub arrays, and this one will cost you O(n) square. So we don't want to have this. And if you guys remember, and then we still have the very effectively way to update the the sub array, which is the difference array. And how a difference array look like? Let's say that we have the array 0 0 0 0 and 0 here, and this one is a difference array. For example, just for example, like I put 0 in here for like the intuition, and then so for example, like we want to update this is the index 1, right? And this one in index 3, and then so for now we want to update the interval between the index 1 and 3 by 2, for example. And then so how can we do this here? So it means that we only need to update the beginning and the end of the array. Okay, so however, like we put it here, yeah, the index next to the end of the array. So the strategy in here is that like we update this one by 2, we keep all of other elements similar, and then we update the next element to the end, the last element of the subarray in here, that is the -2. Okay, so after that we just need to calculate by using the prefix. For example, this prefix would be 0, we have 0, and then here this one is 0, right? And we plus with the 2, we have 2. This one is 0, 0 in here, it plus with this one, it would be 2. Okay, 0 in here plus with 2, that is a 2. And also in here, like we do it here. We do it from here, sorry. So from here we have 0 0 2, and plus with the 0 we have 2, and in here 0 plus with the 2 we have the 2, right? And in here 0 plus with 2 we have the 2, and then in here in the next element 2 plus with the 2 in here we have the 0. So you can see that in here just update the first and the last, the element next to the last element, and then somehow like we can update to all of the elements inside an interval. So this is the difference array, and then we apply the same strategy in here. So let's say that in here, so where should we begin? So let's say that in here we have 33, right? 47, and then 54, and then 41 and 29, right? So let's say that you want to update. So what is the start of the difference array and what is the end of the difference array? So the answer in here is that like you should start from here, right? So why is that? Why is that? Because like in here, let's say that we do not update in this one, remember. So this is our, okay, so this is our, this is our radius, right? This one is the R, This one is the R. Do you update in this index? No, you update in this index. Okay, so you update in this index, it means that like 54. So what is the range of the effect? The range of the effect is what? If you update it from the 54 in here, the range of the effect would be like this. And then this one would be the current index, I mean the starting point of the difference array. And the next element will be the end point. Let's say that we have another element here, and then that would be the end of the difference array, right? Start and the end. So it means that fortunately we can start counting from here, and with the logic of the difference array you can keep updating 19 something here, and if you have any kind of the update in this one, you can plus that one into like the prefix sum of this one, right? Okay, so that is the logic. And then so we can see that in here with any kind of the proposal, and then we can validate that it is true or false, and we based on this we build the binary search for this one, right? If it is true, and then somehow like we will try to increase the lower bound, otherwise we can decrease the lower bound. Okay, so let's program it together. Yeah, so in here I also have very interesting case, because we will talk about it later. Okay, so firstly we need to construct this array, right? Okay, to construct this array we just need to define something like prefix sum, right? Yeah, so let's say that we have n equal to the length of the stations, and then for this we have the prefix which is equal to 0 by the n plus 1, and then so for I in the range, I'm trying to get this array by using the prefix sum by myself. You also can come up with the strategy by yourself. And then so here we have the range of n. The logic in here that is not too difficult, but I mean like different people will have different strategy, right? So just don't want to like make it to become complicated. Prefix of the I, and then we will plus with the stations I. Okay, so for this first one, and then we need to define, I call that is the prefix sum. So for now this prefix sum will be actual this one. It will be calculated from the prefix, and that would be like 0, and then we multiply with the n, and in here so we still need to iterate another time to the end, and then we get the left which is equal to max between the 0 and what's the I minus r, right? And the right, that would be, this is just the boundary, so it is the mean of n minus 1 and the I plus r, right? And the prefix sum, it would be equal to, prefix sum I, that would be equal to the prefix of the right plus 1, and then we minus prefix of left. Okay, so here just simply return 0, and then we will check the prefix sum. Just print this one. Okay, so this is example, and then so we can check that like we can get the same result in here. Same result in here. So yeah, it is safe for us to move forward, and then so we can double check with others. So this one is very easy to satisfy. 3, right? And then so r equal to 1, 11, 9, and 5. Okay, so it means that it is safe for us to proceed the next step. So for this one, I will define the things like that is our valid function, and with the valid function, and we need to validate the power, the number of the we will propose stations. Let's say that we will propose the power. Yeah, so naming convention in here, that is not good. I should not put it that like valid power. So yeah, you can change in here like I will create the difference array which is equal to the 0, and then like we yeah, and I think that in here like we don't the difference array, um, the difference array is just the things like I want to keep it as the accumulations. For example, like in here, let's say that I would want to keep the array like, yeah, it would be like the initialize with the 0, and then if we just put the things like the 19 here, so it would be like 19, and then so we keep counting that, and if we have another things here, and then so we can add it up. I want to split it into two arrays, but it depends on you, so you can still like, yeah, just simplify it using one array. Yeah, so div array that would be equal to the 0, and well, we multiply, yeah, have n elements, and let's say that we have available stations. It means that the number of the stations we can build, and that would be equal to k, right? And then so we have the prefix sum. It will be equal to the prefix sum we have already have here, so we just need to copy that. Yeah, just copy the new element inside here, because like you will use it every time we have the new proposed power. Yeah, so just the logic. So for now we will iterate through the n elements, so number of the stations, and with this one, and then we can see that like what if I mean like if that is a 0, right? If the 0, it means that, for example, like if you approach here, and then so the difference array first element will be 0, and then you will add nothing. However, like from here, so you will add 20, so here like you add 20 or something, so it means that like the next one will be equal to the previous one, and then yeah, so we do that. I mean, yeah, so if I greater than 0, and then somehow we should do in here is that like the different array of I will be equal to the, I mean, we will accumulate the difference of the I minus 1. Why it does? Because in here, remember that like in here this one is like the 0 0 0 0 something, and then like, yeah, so we have that. For example, like for this one, initial line of the different array is 0 0 0 0, right? So it means that, for example, like if I have 19 here, and then so previous one will be equal to the previous one, so this one will be 0. I mean like accumulation, the first one will be 0, the next one will be plus, sorry, 20. It should be 20. 0, right? 20. Let's say that we start from the second one, 20, 20. It means that this one is the initialization, and then we add up from here, right? Add up from here, so it means that we keep adding up the previous element to get the current one. So this is my difference array, and this is the logic for us to implement the accumulation or the prefix sum in the difference array. And then so if we have the things like I want to separate between the prefix and the sum, if this one, I mean, it means that like if this one is the current number, and it plus with the difference array value in here, accumulation, and then it plus with the diff of I, and if this one is like smaller than the proposed power, so in here what should we do? So it means that we need to building station will be equal to the proposed power, and then we should minus this one, right? It means that like we should have built something more stations, and then with this one, if the building station, if this one is larger than the available stations, right? And then what should we do? We return false. It means that this one they does not satisfy the conditions, because we have no more stations to be built. And then so if yeah, so that is the things, and here like if this one satisfy, and then we just like we will update the difference of I will be equal to the building station, right? So because like for now you want to build more, right? It means that, for example, in here you will start from here and then you keep adding up from here, right? So it means that you need to update the first element and the last element of the difference array. That is the logic. And then so yeah, so and this one is like the start of the array, right? And yeah, so this one is the start of the array, and we also need to update the end of the difference array, right? So if the, so this one should be the I plus 2 by r plus 1, right? If this one is smaller than n, this one is just the logic of the difference array, so you can do the search about how can we implement the different arrays. So typically it have the right, left and right pointer, and then so in here like this one is the right of the difference array. And yeah, so why do we do this? For example, in this case we can see that this element is out of bound. So what should we do with this case? Do we need to do anything? No, because like you can see that all the range in here is added up, and then they don't need to remove any kind of the 20 at the end, because the array is I mean like it is out of bound. It means that all the element from here to here, they will be added up. So that's why that is the condition, is to check within the range. And then if it is available one more element in here, for example, so we put just minus 20, because we don't want this element to be affected by the previous range, right? Yeah, so that is the thing. So with this one, so you can update this by using the difference array of the I plus 2 by r plus 1, that is equal, I mean like we will minus the building station. Yeah, so that is the thing. So and all, if all the things like run smoothly and then nothing else is triggered in this in the middle, it means that like we will have the 2. Okay, so for now that is the things like we will program for the binary search. For the binary search, we just have the high and low. So for the high, that would be, so yeah, so for the low and high first, low and high. So for the low, that is the mean of the I mean like that is the mean of the prefix sum, right? That is the mean of the prefix sum, and all the time that is the mean, because we have the mean, right? But we want to find something better, so it means that it be the mean of the prefix sum at the beginning. However, like the max of the prefix sum here, that is not enough. Okay, so I will show you the case. For example, what if we have the for 2? So it means that like the number of the stations we can serve for each city is 66. And what if the I equal to 1 and the k equal to 1, right? So what does this mean? This means that you need to remember that you must build one station. So it means that you need to add it up here. So it means that in the case you choose, like this case or this case, it also affect to your solution, as this would be 7, right? Because like the r in here is equal to 1. So I got this error. So you can see here. So that is the 7 instead. So I found this one by mistake. Yeah, so we can learn from the mistake. So here like to fix this one, it means that the max should be like max of the prefix sum plus the k. Okay, so for now that is the easy thing. So the answer will be initialized as the low value. And for now, if we have the low smaller or equal than the high, we will iterate through everything. So we have the mid value, that is like the high plus low, and divide by 2, so we get the mid value, right? And then so for now, the we will check if the valid power of the mid, and then so what should we do? What if it valid, and then we just get the answer equal to the mid first, and then we will get the lower bound, increase the lower bound, right? That would be to equal to the mid plus 1, right? We keep searching. So for now we have the search space, and then so for now, for example, this point is satisfied. Okay, we don't need to care about this one because we are finding the max. We're finding this one. Okay, so this one, because it has already included the midpoint, So we will start from mid plus 1, right? So yeah, so that is the logic. And else, what if it does not satisfy, and then we have nothing to do except doing the high equal to mid minus 1. Okay, so that is our logic. And then so after this, and we just return the answer. Okay, so difference of I will be the building stations, maybe some of the star, yeah, building. Okay, I usually got the typos error when I try to like make the code again. Okay, building station. Okay, so for now we can see that it can run. And so yeah, let's check a little bit. Yep, so I think this code is fine. Yeah, however, some problem in here, like we have the prefix sum. If building station lecture, then we forget to get the update we need to update the available station as well. So it means that the available stations will be like, if this one happen, and then we need to update the available station where we need to reduce it from the available station. Right, so this is the testing result, and then somehow like we can see here, if we try this one with the 53, right, and it does not satisfy the conditions, however it satisfy the conditions with the 52. Okay, so just submit. Yep. Yeah, I think like this solution is like very popular, and most of people come up with the same solution as me. Yep, so I think that's all the things for us today. So the difference array, whenever you want to update the maybe subarrays or an interval of the array, and then so just think about the difference array. That is very effective one. Yeah, so I think that this video is pretty long, and thank you so much for watching my video. And if you like, and if you want to give me more motivations to do more videos for you guys, please give me a like or comment. So I must say that is the only motivations for me to continue doing the videos every day. And thank you so much for watching my video, and see you next time.